We're going to start with substitution. That's why it says algebraically part 1. So following these steps when solving by substitution, step 1, we solve one equation for one of the variables. So your goal is to get either x by itself or y by itself. Then we're going to substitute the expression for the first variable into the other equation and then solve for the second variable. Then we substitute the second variable's value into the keyword substitute. And then we're going to solve for the first variable. Here we will plug into step 1. Okay. And then we check the solution in the other original equation. So we're going to check, make sure we did it right. So let's go and jump on. So example 1, we have 4x plus 3y equals 10 and x plus 2y equals 10. Step 1 tells us to identify which one of our systems or part of our system would be the easiest to get a variable by itself. It would be number 2. That's because x is almost by itself, right? What would I need to do to get x by itself? I would need to subtract the 2y, right? So that leaves me with step 1 completed. X equals 10 minus 2y. Okay. Then on step 2, it tells us to substitute the expression that we get back into the other equation. So we're going to substitute x into this equation. So when we substitute, I'm going to change colors. I'm sorry. So we have 4x plus 3y equals 10. And where x is, we're plugging in 10 minus 2y. So it becomes 4 times 10, yes, minus 2y plus 3y equals 10. So we substituted that in. And now we're going to solve for y. So I'm going to distribute. 4 times 10 is 40. 4 times negative 2 is plus 3y equals 10. Combine like terms. We get 40 minus 5y equals 10. Isolate the variable. So I'm going to subtract 40. And I get negative 5y equals negative 30. Divide by negative 5. And y equals 6. Okay. So we've got y equals 6. Now we're going to take the value that we got from there, and you're going to plug it back into step 1. So I'm taking the y that I got here and plugging it back into step 1. So step 3, we would have x equals 10 minus 2y, but now we have a value for y, which is 6. Plug it in, and we get 10 minus 2, 12. And what's 10 minus 12? Negative 2. So x equals negative 2. And then step 4 is to check our answer using the one that we didn't touch. So we didn't change 4x plus 3y. So we're going to use 4x plus 3y equals 10. And we're going to plug in the variables that we have, negative 2 and 6. So 4 times negative 2 plus 3 times 6 doesn't equal 10 is our goal. What's 4 times negative 2? What's 3 times 6? Does negative 8 plus 18 equal 10? No. Yes. It does. So therefore, our solution is x comma y, negative 2 comma 6. Okay. What you guys say so far? Any questions, comments about any of the steps? Okay, so on our first example, we went through and did it like pretty much piece by piece. And then when we do the practice, we're going to work it as if I'm working it as if I'm a student. Okay. So are you going to always have the little boxes that are set up on your notes? I mean, if you're going to draw them, sure, but you may not. So therefore, how would it look if I'm just working this problem on its own?
I like that red answer in the solution box.
Yes, that's your,
one that goes in there?
yes, this is your solution. Okay, are we ready? We're gonna do it as if, no boxes, right? All right, so step one is to decide which one of the equations are you gonna use? Which one should we use? 1 or 2? 1, because x is almost by itself. What would x equal once it's by itself? Do you understand why it equals 5 plus 2y? Yes. Okay, then step 2 is I'm going to take this x, and plug it into this x, right? So step 2, I have 4 times 5 plus 2y plus 3y equals 9. Now I'm going to solve for y. So I distribute, gives me 20 plus 8y plus 3y equals 9. Combine like terms, we get 20 plus 11y equals 9. Then we're going to isolate the variable. So we're going to subtract 20. Okay, so when we subtract 20, we have 11y equals negative 11. Divide by 11. So therefore, y equals what? Negative 1. Okay. So step 3 is I'm taking this value and I'm plugging it back into step 1, right? I'm taking this guy and it's going into there. So we have x equals 5 plus 2 times negative 1, which is 5 minus 2, which equals 3. So x equals 3. Step 4, if I'm not comfortable or sure about my answer, there's one way to figure it out. I'm going to use the one that I did not touch in the beginning. So 4 times 3 plus 3 times negative 1, does it equal 9? So we have 12 minus 3, does that equal 9? Yes, that is a true statement. So therefore my solution is 3 comma negative 1.
Wait, so step 4 is checking it, or?
Step 4 is checking it. Okay. All right. So without me talking, without me saying anything, I'm going to put 3 minutes on the clock. All right. So you should have used equation 2, right? So you should have started here to get x by itself. Remember when you're getting the variable by itself and you're moving across the equal sign, you have to change the sign. Okay.
That's not why I did that part, right?
All right. So you're working with x equals 12 minus 2y. That's your step 1. Step 2 is I'm going to plug that into the other equation. So I have 7 times 12 minus 2y minus 3y equals negative 1. Distribute. I get 84 minus 14y minus 3y equals negative 1. Combine like terms, I get 84 minus 17y equals negative 1. Isolate the variable, subtract 84, and I'm left with negative 17y equals negative 85. Divide by negative 17, and you get y equals 5. I'm going to take this and plug it back into step 1 for step 3. So we have x equals 12 minus 2 times 5. That gives me x equals 12 minus 10. So what does x equal? 2. Okay. To check myself, I'm going to plug it into the one that I did not start off with. So 7 times 2 minus 3 times 5 needs to equal -1. Does 14 minus 15 equal -1? Yes. So therefore my solution should be 2, comma, that's a, not a 5. That's what it is. And that should be your solution, 2, comma 5. All right, how do we do? If you made a mistake, do you see where you made your mistake at? Huh? If you don't, speak now so that I can know where to help you before we learn the next way of solving this. Okay, so we're going to go on to method number 2. Method number 2 is called elimination. Elimination. It's on the other side. Okay. Elimination, it depends on the problem. So you know how in these previous problems, one variable was almost by itself, right? And these next problems, there will not be a variable that's by itself. Okay. So here we go. So the steps for elimination, you want to arrange the equations with like terms in a column. So basically you want to make sure we're in AX plus BY equals C format for all of our, it's called our standard form, remember? The goal is that you need one pair of the coefficients to be opposite signs, which means that one needs to be positive and the other needs to be negative. You want to find the least common multiple. Least common multiple is the smallest number that each coefficient divides into. And then we're going to add the equations and solve for the remaining variable. Okay, step 5 is a little bit flexible. Step 5, we either can substitute what we got into step 4 back into one of the originals, or we can repeat steps 1 through 4. Okay, and then we check our solution. Again, we tend to do elimination when one variable isn't easily enough to isolate. So notice here, we have 2x minus 5y equals 11 and 3x minus 2y equals -12. Are either one of the variables isolated in either one of these expressions? No, it's not. So here we're going to go through elimination. So step 1 is to make sure that they are lined up and decide which variable are you going to cancel out first. It doesn't matter which one you decide at all. So let's say we decide we're going to cancel out x's first. Okay, so that's step 1. Step 2 is to determine what is the LCM, not LMC. What is the LCM between their coefficients? What is the LCM for 2 and 3? 6. The least common multiple is 6. Okay, so you're going to ask yourself, what would I have to multiply the first expression by to turn 2 into 6? You have to multiply it by 3. What would I have to multiply the second expression by? I have to turn it into 2, but I'm going to have to turn it into a -2 because I need one of them to be positive and one of them to be negative. So I'm going to multiply every term, not just the first term. So we're going to write it out for like you seeing what we're doing, but you don't have to write it out like this every single time, okay? So 2 times 3x minus 5 times 3y equals 11 times 3. 3 times -2x minus 2 times -2y equals -12 times 2. So my new system that I'm working with is going to be 6x minus 15y equals 33. Negative 6x plus 4y equals 24. We're about to do step 3. That was step 2.
Wait, so at the end of the second equation, that is supposed to be positive?
No, it's not.
No, it's not. The negative 2 was supposed to be.
I just forgot. A negative times a negative is a positive. Because we have to have opposite signs. Remember on step 1? Okay. Are we good? So what happens? Are my x's going to cancel out like I planned? Yes, they do. And I'm left with negative 11y equals 57. And sorry, this is step 3. And then step 4, solve for the remaining variable. What would I need to do to get y by itself? Divide by negative 11. So y equals negative 57 over 11. It is okay. Fractions are our friends. Fractions are our friends. So we have the y. Now at this point, you have the choice to repeat steps 1 through 4 or substitute this fraction in to one of these expressions. As a class, I would like for y'all to decide, do we want to substitute the fraction or repeat steps 1 through 4 and this time eliminating y? We're going to substitute? All right. So substituting, I'm just going to choose the first one. So we're going to work with 2x minus 5y equals 11. And we're going to substitute in for y. And what are we substituting in for y? Hey, look, they chose what they chose, Luke. They chose what they chose. Equals 11. Now, fractions. I know you guys freak out when you see fractions, but fraction is just division, right? And what's the opposite of dividing by 11? Multiply by 11. So I can multiply every term by 11. And what happens is it eliminates the fraction. And now I'm working with 22x plus what's 57 times 5? 5, 3, 285 equals 121. A fraction is only a problem if you let it be a problem. So I subtract 285, subtract 285. It's 121. So we get 22x equals negative 164. Divide by 22. And we get x equals, both of these are even, so they're divisible by 2. So negative 82 over 11. That's our x. If you were not very confident in your answer, what would you do? Check. So I could take these values and check them. So I could, let's use this guy. So 3 times negative 82 over 11 minus 2 times negative 57 over 11 equals negative 12. What did we say the opposite of dividing by a number is to do? Multiply. So I can multiply each term by 11, and that gets rid of my denominator. So 3 times negative 82 is 6, 246. Negative 2 times negative 57 is positive 114. And this is negative 132. Is this a true statement? Yes. So my solution is negative 82 over 11, comma, negative 57 over 11. Okay, I deliberately want to do a fraction because you guys freak out when you see fractions, but you don't have to. Okay, all right, let's do the practice. So on the practice, we're gonna work it as if we're comfortable. Deciding which one do you want to eliminate? X or Y? Does it matter? No. I'm gonna go with, I already boxed X. Luke, you made a decision too late. I'm gonna go with X. And so the LCM is going to be 12. The LCM between 3 and 12 is 12. So I don't have to change the first one, but I will have to change the second one. And I'm gonna go ahead and multiply this by negative 4. And what I do to one side, I have to do to the other. All terms have to be multiplied by negative 4. So now I'm working with 12x plus 8y equals negative 8. And my new one on the bottom is negative 12x minus 16y equals negative 8. What happens to my x's? Cancel out. And I'm left with negative 8y equals negative 16. So step 4 says to solve for y. And what do I do to solve for y? Divide by negative 8. And we get y equals 2. So step 5 says I take this y and I plug it into one of these equations. I usually choose the one with the smallest numbers. So 3x and 4y are the winners. So 3x plus 4, instead of y, I'm putting a, equals 2. That gives me 3x plus 8 equals 2. To get x by itself, I'm going to subtract 8. Leaves me with 3x equals negative 6. Divide 3. And we get negative 2. To be like, oh, this is all right. I think I did it right. But to do my final check, I'm going to plug it into the other one that I didn't use, or either one actually, doesn't really matter. But usually the other one. So 12 times negative 2 plus 8 times 2. Does it equal negative 8? That gives me negative 24 plus 16. And it does equal negative 8. So my solution is negative 2, comma 2. All right. Your turn. Practice 2. Your turn. We are under the 10. To start off with, they're lined up standard form, and we can decide to eliminate our x or our y. The good thing about this problem is that one's already negative and one's already positive. So that makes it super duper easy. So I asked myself, what is the LCM of 2 and 10? And the LCM is 10. So what do I need to multiply 2 by so that it can be a 10? 5. So I'm going to multiply 2 by 5, 4 by 5, and 2 by 5. So now I'm working with negative 10x minus 20y equals 10. And then I have 10x plus 20y equals negative 10. And what happens here is everything becomes equal to 0. When this happens, the solution is infinite solutions. Infinite solutions. Okay? Now, side note, if you end up where one variable, where it comes down to a number not equal to a number, that would be no solution. Okay? Like if it said 0 equals 4, that means that it is no solution. Okay? All right. So you should have gotten your classwork / homework. It's not due till Wednesday. So you'll have class time, a little bit of class time tomorrow after the quiz.